Welcome to Lesson 6 on the topic of excise taxes. Chapter 7 covers a number of different types of taxes, and we're going to focus first on this one particular type, which is about the simplest that we can analyze using the tools that we have at our disposal. We're going to use, to analyze an excise tax, we're going to use supply and demand, consumer-producer surplus, deadweight loss, elasticity of demand and supply. Pretty much all the concepts that we've done for this semester so far are going to be put together into this analysis. So it's a good one to kind of sum up to. So first, let's talk about what an excise tax is. An excise tax is it's also known as a per unit tax, meaning it's a certain amount of tax per unit of the goods sold. The classic example of excise taxes is on cigarettes, and here's some data on cigarette excise taxes, which vary by state. You can see that here's Indiana with just under $1 per pack excise tax, which ranks us 31st. That's the 31st highest. The first is New York with $4.35, and that's just the state excise tax. Cigarettes cost more than $10 a pack in New York City because of a combination of state, city, and federal taxes. There's also a federal excise tax on cigarettes, which applies on top of the numbers you see here, which latest is $1.01 per pack. So anyway, there's a combination of excise taxes on cigarettes, and they're mostly used, obviously, to deter smoking and also to raise government revenue, but with the nice side effect of hopefully deterring smoking. Anyway, the way that it works is that this amount would be basically owed, the state amount, this 9.995 per pack, would be owed to the state by the seller for every pack of cigarettes they sold per year. So it's paid to the government by the seller of the good. So for cigarettes, it'd be, like your convenience store, your gas station producing a report at the end of the year. This is how many to the government. This is how many packs of cigarettes we sold, and therefore this is the amount of money we paid or still owe in taxes for that. So an excise tax is often used to deter behaviors the government wants to deter, like smoking. There's excise taxes on fuel inefficient vehicles, on alcohol. There's been excise taxes over the years on certain imports when we want to kind of protect the domestic industries against the imports. So anyway, that's a common purpose of the excise tax, and the assumption behind this is that if you add an excise tax onto something, then it's going to, one goal would be to reduce the quantity of it that's sold, typically. Another obvious goal is to raise government revenue. And then sometimes the question is asked, and really should be asked when an excise tax is being considered by a government, what's the effect going to be on consumers and producers? We might just think, well, doesn't it seem as obvious as if there's $1 excise tax per pack on cigarettes, then won't it just cost consumers an extra $1 per pack, and won't that basically be what the cost is? Well, it turns out the answer is no, because of the way that demand works and because of elasticity of demand, and we'll look at all that stuff. What ends up happening is that an excise tax has some effect on both consumers and producers. It does raise government revenue and reduce the quantity sold. The effectiveness of meeting all these goals depends a lot on the relative elasticities of demand and supply. So that's a little preview of kind of where we're going with this. So now let's jump into the analysis using the graph. What we've got in front of us here is a graph of just standard supply and demand. If we look at S1 and D being the original supply and demand for a good. So let's call this the quantity of cigarettes. Oops. And let's say the original price of cigarettes is going for $4 per pack. That would be the P1 equilibrium. Here's the equilibrium point, supply and demand, equilibrium quantity. in the absence of any tax. So that's point one, without a tax. Cigarettes are selling for $4 a pack. Then let's say the government adds this. What's the effect of adding a $1 per pack excise tax onto this market? So here's what would happen. The best way to think about this is that without the tax, sellers are willing to sell Q1 units of this good at a price of $4, but now they need to send $1 away to the government for every pack that they sell. That means that whereas before the tax they were willing to accept $4 per pack, now to get that same amount they've got to get $5 per pack. I'm putting that up here for a specific reason. The distance here between this point and this point shows the difference between the seller's willingness to accept or willingness to sell this quantity before the tax and after the tax. Therefore, the difference between those two, the distance there, the vertical distance, should be the amount of the tax, should be $1. That's also marked just right next to it as, I'll put equals this vertical distance here, T for tax. So now it's like we've created a new supply curve. It's kind of like we've decreased the supply, shifted it to the left compared to the old supply curve. You know, we could put an arrow that shows it kind of going like that, and that would look a little bit more like standard supply and demand. But basically what we've done is created a new supply curve that is the vertical distance of the tax above the old supply curve. And notice that this point here corresponds with $5. But cigarettes will not end up selling for $5 as a result of this tax. Now, why is that? Well, it's because we have a downward sloping demand curve. Because of the way that the demand curve is structured, the new equilibrium of supply and demand will be here, not up here. If cigarette manufacturers, if sellers tried to sell cigarettes for $5 per pack, they could do that, but the market equilibrium would win out, because at $5 per pack there'd be an excess supply of cigarettes. There'd be a lot less people willing to buy them than there would be makers wanting to sell them. Assume for a minute that cigarettes have kind of standard elasticity of demand. I know you're probably already thinking we've talked about in class, seen worksheet examples where we talk about how inelastic the demand for cigarettes is. Well, let's just assume for a second that that's not really an issue, that there is a somewhat at least elastic demand for cigarettes. So anyway, there would be an excess supply if they jack the price all the way up to $5. So the market will settle at this somewhat lower price, this P2, which we can't say exactly what it is unless we have a lot more data than this, but we know it's somewhere in between $4 and $5. So let's see what we've shown so far. We've shown that one of the effects here is to increase the price, and we've also, if we take this new equilibrium down to the quantity axis, we've decreased the quantity sold. But we haven't increased the price by the full amount of the tax. We've increased the price by less than T, T being the amount of the per unit excise tax, in this case $1. So that's one piece. Yes, we've reduced the quantity sold. Go back to our goals here. We've reduced the quantity sold. Now let's get into the effect on consumers and producers. We've hinted at that already with the change in price. Let's look at it in terms of producer and consumer surplus. Okay, so the consumer surplus after the tax, let's do all this after the tax to keep our graph from getting too crazy messy. We're going to go below the demand curve and above the new price. That's our consumer surplus. And our producer surplus we could show in either of two ways. And this part's a little bit complicated, so let me show it to you in two different ways, and hopefully you'll just kind of catch on to either one or both of them. We could take, here's the new price, here's the new supply curve, here's our producer surplus. That's pretty simple. But I think it's actually going to be a little bit more helpful. I'm going to erase that because it's going to be a little bit more helpful to show the producer surplus someplace else. Since these two supply curves are parallel, and since these two price lines are parallel, we can get the exact same area as this by taking this triangle here, if we were to extend that supply curve all the way to the y-axis. And I'm going to find it a little bit useful to do that, just to try to mark off some things on the graph. So you'll see what I mean in a minute. Okay, so I've taken off those previous markings for producer surplus, and now I'm going to put back in there a producer surplus marking that's down here, because that represents the producer surplus in the same way that the triangle just below consumer surplus also represents producer surplus. And that'll just help our graph make more sense visually. Okay, so right now we can see a comparison between what was part of the surplus at equilibrium and what's part of the surplus now after the tax. So the equilibrium before the tax versus the equilibrium after the tax, I guess is a better way to put it. We can see that we have lost some producer and consumer surplus in here. So where has this gone? Well, there's a part of this that has gone to the government revenue. That part is this rectangle here. Because this vertical distance here from the top to the bottom of the rectangle is the amount T, and this horizontal distance here is the amount Q2, which is the amount that the government is selling, or I'm sorry, which is the amount that producers are selling. And the revenue government's collecting, remember it's collecting $1 per pack, and the amount of packs sold is Q2. So the government revenue is equal to T times Q2, which is also the area of this rectangle here. Okay, the rest of this, we've seen this before. These are missed opportunity transactions. These should have happened, but they didn't, and we're losing both producer and consumer surplus from those. So that is deadweight loss. Just one note real quick, it does seem a little funny to talk about deadweight loss to society from less smoking, which seems like a good thing, and that is true. If you picked up on that, that is sharp, good job. There is another kind of twist to the cigarette example, which we're not going to get into in this lesson, but we'll get into later in the semester. It's called a negative externality. So when something has negative side effects, that changes a lot of this story, and we'll get more into that later in the semester. Anyway, for now, just consider, if this was any good that you saw an excise tax with not just cigarettes, there would be some missed opportunity transactions, some lost producer and consumer surplus, and some deadweight loss as a result. Okay, let's go back to this box here that represents government revenue. And let me transfer this. I'm going to just kind of pretend that we're transferring this box over here. Okay, we said this is T, this is Q2. And cutting right about through the middle of that box was the original price, P1. And at the top of that box is P2, and down here I labeled as P2 minus T, which makes sense if the top is P2 and the vertical distance here is T. I'm going to call this P2, this is the price that consumers pay. And P2 minus T is the price that producers get to keep because they're sending off T in tax to the government. They don't get to keep that part of it. Okay, so out of this government revenue, consumers are paying this much more, the difference between P2 and P1 in taxes, times the quantity that they're paying, this Q2. So that top amount, everything above the original price, is what we would say is the effect, the impact on consumers of this tax. Specifically, it's called the consumer incidence of the tax. Whereas below, everything below P1, producers used to be receiving P1 per unit. Now they're only receiving P2 minus T. So they're paying, we would say, this much to the government of the government revenue in the less amount that they're getting to keep from these transactions. And we'd call that producer incidence of the tax. So if we had all the numbers, which we don't, if we had all the numbers to measure the amounts there, we'd be able to measure the consumer incidence of the tax and the producer incidence of the tax. And again, that just means the amount of the tax revenue that is, in a sense, paid by consumers versus the amount that's paid by producers. So this excise tax, which we said at first glance maybe seems like it'll just be passed on to consumers. Consumers will be paying $1 more per pack. We see that in reality what will happen is that the consumers will be hit with some of it and the producers will be hit with some of it. There will be government revenue generated and will reduce the quantity sold. We'll also generate some deadweight loss as a result of the tax. And that overall is bad for society. Again, not taking into account the whole point that cigarettes are bad for you and society. But with that aside, deadweight loss is bad in terms of efficiency. Okay, so there's our excise tax analysis. A lot of markings out of that. It gets a little bit complicated. Hopefully you've been able to follow along, and I've split it up into enough parts that you can kind of take each part separately if needed, and we'll do problems to help you practice that. Okay, let's do one more thing. This will be simpler now that we've done all those the basics. What we want to do is say what difference does it make? What are the types of goods where the incidence of the tax falls more on consumers, and the types of goods where the incidence of the tax falls more on producers? If the government knows this, it might be able to tailor the tax, if it wants to keep consumers from having to pay much at all. It could find certain goods that might be able to do that, or vice versa if it wants to protect businesses. Also, if it wants to, has particular goals for how much it decreases quantity. It depends on mainly the elasticity, as you see from the slides here. Depends on the elasticity of demand, and actually the elasticity of demand and supply. Because when we say relatively inelastic demand, we're saying that the elasticity of demand is less than the elasticity of supply. Whereas when we say relatively elastic demand, we're saying the elasticity of demand is greater than the elasticity of supply. So relative being relative to the elasticity of supply. And I think this is really easy to see on the graphs. So let's take each one at a time. So if you have relatively inelastic demand, and cigarettes actually would be an example of this. So let's stick with our cigarettes example. Remember, a pretty vertical demand curve like this one here does show relatively inelastic demand compared to a flatter supply curve. And you can see just what happens when we put an excise tax on a relatively inelastic demand curve. We shift the supply curve up by the amount T. We've got our new price P2 compared to our old price P1. Let's sketch out, to show the incidence, let's sketch out the government revenue box as well as the consumer incidence and the producer incidence. For the government revenue box, you take it from our new equilibrium and drop the line down to our old supply curve and then across. That's the amount of government revenue, because there's our T and here's our Q2. And now we can just barely see at the bottom this old price P1 kind of peeking its way above the bottom. So what that's showing us is here the consumer incidence is most of this government revenue box. Consumer incidence is this top part, everything above the old price, whereas the producer incidence is this tiny sliver down here of the government revenue box that's below the old price. So what we've shown in this graph is that with relatively inelastic demand, the consumer incidence is greater than the producer incidence, and that the decrease in quantity is not very big. We've got a small decrease in quantity. All this makes sense if you just think of cigarettes. We would predict that with an excise tax on cigarettes, since it's relatively inelastic demand for cigarettes because people are addicted, then producers are going to be able to pass on more of that cost more of the cost of the tax to consumers. Consumers will still keep buying it even when the price goes up, so producers will pass it on to them, and consumers won't buy that much less. So both of those things make sense. By the way, there's actual data on this. Here's one place I found it quoted. The citation is not very good. It says that studies show that for every 10% increase in cigarette prices, youth smoking drops by 7% and overall consumption falls 4%. So that's inelastic demand, but maybe not as inelastic as you might think. It's an elasticity measure for the overall of 0.4. It's not like people keep smoking no matter what, I guess is what I'm getting at. Okay, so there's with relatively inelastic demand. With relatively elastic demand, let's do the same thing. So to show relatively elastic demand, we've got a flatter demand curve compared to a steeper, more inelastic supply curve. If we put a tax of the amount T on this good, then we shift the supply. Here's our first equilibrium, here's our second equilibrium. And to find the government revenue box, we go from our second equilibrium point, drop down to the original supply curve, and then extend that. So there's our government revenue. It's T, and that's Q2. Use the same colors. Our consumer incidence is everything above the old price, and our producer incidence is everything below the old price. So we can see pretty obviously from this one that the consumer incidence is less than the producer incidence, and we've got a relatively larger decrease in quantity. Again, with relatively elastic demand, this makes sense. So let's go with some of our elastic demand examples. Fast food along 86th Street, and since there's got to be lots of substitutes, let's just say the government puts an excise tax on only burritos, a burrito excise tax, but not on hamburgers or pizza or things like that. So there's lots of substitutes for burritos along 86th Street, so demand would be fairly inelastic. If the government puts an excise tax on it, then producers, Qdoba and Chipotle, are not going to be very able to pass along those prices, those taxes to you. They're going to have to pretty much eat a lot of it to keep from raising their prices too high that you'll go somewhere else. So most of that tax will be paid by the producers, and less of it will be paid by you, the consumer. So there's our general rules. When you've got relatively inelastic demand, then the consumer incidence is larger and you get a small decrease in quantity. With relatively elastic demand, the producer incidence is larger and you get a larger decrease in quantity. Okay, there's demonstrations of all our analysis we're going to do with excise taxes. I will see you in class.